Hello students, it's Mrs. Cinti and I am here to talk to you about solving division equations. Okay, so we just did solving multiplication equations and we used it by dividing both sides by the multiplication number. So let's go ahead and just review that real quick. So we had something like 6x is equal to 12. We needed to isolate that x value, so what we did is we divided both sides by positive 6, divide by 6, and then we get x, because it's now isolated, is equal to 2. Okay, and then we can check again. 6 times 2 is indeed equal to x, is indeed equal to 12. Excuse me. So what we're doing is, and we did this by using the division property of equality. Now what we're going to do is we're going to start to look at questions that look a little bit like this. X over 12, so x divided by 12 equals 3. It can be written in your books like this, right? It means the exact same thing. This is a little harder to work with, so if you do see this in your textbook, go ahead and switch it to this right here. What we'll be using is we'll be using the multiplication property of equality. Okay, we'll be using this, okay, the multiplication property of equality, which means that when you multiply both sides of an equation by the same number, so times 3, let's say, times 3, you will have a true statement again. Okay, so that's what this means. So what we're going to do is we're going to still isolate the variable. It's worth writing again, isolate the variable. I think it's also a little calming when we start looking at bigger and bigger equations and bigger like combining terms, all of those things, by reminding us that we're isolating the variable is a way to kind of center yourself back to the equation. So what you're going to do is, if it's x divided by 12, we need to get rid of that 12. Because this is division, if I multiply by 12, it really looks like I'm multiplying 12 over 1. Okay? What that does is it gives us 12x over 12, which is the same as dividing by 12. Okay? So that's why that works out. But you don't have to write all of that. You don't even have to write the over 1, except if it helps you see it a little bit better. And so what you're going to do is, by doing that to both sides, you're canceling this out. You get x by itself, nice and isolated, and then you get your answer, your solution. Okay, so as it turns out, 36 divided by 12 is equal to 3, and we circle our answer. Okay, let's look at another example. As long as we continue to isolate our variable, we're just fine. What if we have something that looks like this? 1/6 u is equal to negative 40. Okay, what does that look like? Now remember, okay, I'm doing this to kind of mess with you a little bit. That u is really u over 1, right? Unless it has a 1 over it, it's a whole number and it's over 1. So that means that 1 times u is really u over 6 times 1, which is really 6. So it really is u over 6. It's just a less familiar format. Okay, so don't forget that that's still available. So we multiply both sides by 6. 6u divided by 6 is 1. We get, and we multiply this side by 6, both sides by 6. U is equal to a negative 240. Okay, negative 240. Very nice. Let's look at another example. A over, that looks like a terrible A over 10 is equal to the opposite of the absolute value of 13. This means that we want to solve this first before we try to isolate the term. So we rewrite A over 10 is equal to this opposite of how far away negative 13 is from 0. So it is 13 steps away from 0, so this would come out as a negative 13. Okay, then what we'll do is we'll multiply both sides by 10, cancel, A is equal to negative 130. Now, what happens if all of these, the variable has been on top? So let's go ahead and add one little curveball here and see how we'll solve it. So let's say that we have, let's say, I don't know, 10 over x is equal to 2. Let's do that, okay? So what we'll do is we'll try to, again, isolate the variable. In this case, if we multiply by 10, and this is a mistake that a lot of students make, so don't make this mistake. If we multiply by 10, this is wrong, right? We will get, that's really multiplying by 10 over 1, we will get 100 over x is equal to 2. Did we simplify anything? No. Well, we would multiply both sides by 10, so we'd get 20. So basically, we can still solve it, but we didn't make it easier. We just made it bigger numbers, right? We just kept the problem the same. So we need to get x by itself, and this is going to require an extra step, okay? So what we did here was wrong. Again, I do not want you to think that this is right, okay? We do need to multiply. Division is undone by multiplication, so we are going to multiply both sides by something, but we are going to multiply both sides, by x. Multiply by x, multiply by x. What this does is we have the x over 1, it gives us 10x over x. We can cancel x out here. We get 10 here, and we get 2x here. When we now, it's a familiar problem, right? It's not a division anymore per se. We're going to undo it with division, right? Divided by 2, we get 5 is equal to x. We put the variable on the other side, but we did it in order to get a lovely positive and a whole number. Okay, great. So go ahead, go crazy with section 2.7, solving division equations, and I'll see you next section for solving two-step equations.